Welcome, dear explorers, to another contemplative journey with Earth with nature. Tonight, under the quiet canopy of a starlit sky, we invite you to ponder a question as vast as the cosmos itself. Is Earth merely one of countless worlds scattered across the universe, or are we a singular miracle in the endless void? Let's embark on this slow, immersive voyage through the realms of astronomy, exoplanet discoveries, and philosophical musings on habitability and fragility. Picture yourself gazing up at the night sky, each twinkling star a potential home to unseen worlds, as we unravel the mysteries of our place in the grand cosmic tapestry. Settle in, breathe deeply, and let's dive straight into the heart of this cosmic wonder, exploring the science and stories that shape our understanding of life beyond our pale blue dot. As we begin, imagine the Earth as a tiny, fragile orb suspended in the infinite dark, a precious gem that might not be as unique as we once thought. Our journey tonight will traverse the latest findings in planetary science, the awe-inspiring hunt for exoplanets, and the deeper reflections on what it means to be a habitable world. So, let's start with the first spark of curiosity. How do we even begin to search for other Earths in a universe so unimaginably vast? The answer lies in the incredible advancements of modern astronomy, where telescopes like Kepler and TESS act as our cosmic eyes, peering into the depths of space to detect faint dips in starlight, evidence of distant planets passing in front of their suns. These instruments have revealed thousands of exoplanets, many in the so-called Goldilocks zone, where conditions might just be right for liquid water and perhaps life. Consider this. As of today, over 5,000 exoplanets have been confirmed, with estimates suggesting trillions more exist in our Milky Way alone. Each one is a potential story, a world with its own skies, landscapes, and mysteries. Picture a planet like Kepler 452b, often dubbed Earth's cousin, orbiting a star similar to our Sun, with a year just 20 days longer than ours. Could it harbor oceans, forests, or even beings gazing back at us? This isn't science fiction. It's the frontier of planetary science facts, where data from light spectra tells us about alien atmospheres, hinting at gases like oxygen or methane that could signal life. But let's pause for a moment. How does it feel to know that our Earth, with its sprawling oceans and whispering winds, might be just one of many? Does it make you feel smaller? Or does it ignite a sense of connection to something far greater? As we sift through these exoplanet mysteries, it's not just about numbers or data. It's about imagining the possibility of a second home, or even a mirror to our own fragility. Transitioning deeper, let's think about what makes a planet habitable. It's not just about being in the right zone. It's a delicate balance of atmosphere, magnetic fields to shield against cosmic radiation, and geological activity to recycle nutrients. Earth's magnetic field, for instance, is a silent protector, deflecting solar winds that could strip away our air over millennia. Venus, our closest sibling, shows us the dark side of habitability. Once possibly Earth-like, it now suffocates under a thick, toxic atmosphere, a runaway greenhouse effect turning it into a hellscape. This contrast is a stark reminder of how fragile life's cradle can be, a fact underscored by missions like NASA's Magellan, which mapped Venus's scorched surface in haunting detail. Now imagine a world like Proxima Centauri b, the closest known exoplanet, just 4.2 light-years away. It orbits a red dwarf star, potentially tidally locked, with one side in perpetual day and the other in eternal night. Could life adapt to such extremes? Scientists are using simulations and upcoming tools like the James Webb Space Telescope to probe these questions, seeking biosignatures in the light that filters through alien skies. These endeavors aren't just technical feats. They're emotional investments in our future, a quest to understand if we're alone or part of a cosmic family. Let's linger here. What emotions stir in you when you think of a universe teeming with hidden worlds, each a potential sanctuary or cautionary tale? The science of habitability teaches us not just about other planets, but about safeguarding our own, a lesson woven into every volcanic ridge and ocean current on Earth. As we expand our gaze, let's consider the philosophical weight of these discoveries, a topic we'll explore next, where the line between science and wonder blurs into profound questions about existence itself. Now, let's gently shift our perspective to the philosophical undercurrents of this cosmic search, a realm where science meets the soul. Here on Earth with nature, we don't just chase facts. We ponder their meaning, letting the vastness of space inspire introspection. If Earth is one of many habitable worlds, what does that say about our purpose, our uniqueness, or even our responsibility? Imagine standing on a distant exoplanet, looking back at our sun as just another star in an alien sky. Does it diminish us, or does it expand our sense of wonder? Philosophers and scientists alike grapple with the anthropic principle, the idea that the universe seems fine-tuned for life as we know it, with constants like gravity and the strength of atomic bonds perfectly aligned for stars, planets, and biology to emerge. If there are countless Earth-like worlds, does this fine-tuning become less miraculous? Or does it suggest a deeper, hidden order? Consider the Fermi Paradox, a chilling puzzle in planetary science facts. If the universe is brimming with potential life, where is everyone? Are we alone because intelligent life is rare, self-destructive, or simply beyond our technological reach? These questions aren't just academic. They tug at our emotions, stirring a mix of hope and existential unease. Let's paint a picture. The SETI Institute, with its array of radio telescopes, listens day and night for whispers from distant civilizations, scanning frequencies for a signal that could change everything. So far, silence reigns, but each quiet moment is a reminder of how precious our voices, our cultures, and our planet are. Technology like the Breakthrough Listen project pushes this boundary, using AI to sift through petabytes of data for anomalies. Imagine the day we detect a deliberate pattern, a message from another world. What would you say to them? What would you ask? This search for connection mirrors our own history. Think of the Voyager probes, launched in 1977, carrying golden records with Earth sounds, from whale songs to Mozart, a time capsule of who we are. These artifacts are now over 14 billion miles away, drifting through interstellar space, a testament to our longing to be known. As we reflect on exoplanet mysteries, we see Earth not just as a physical home, but as a repository of meaning, a fragile arc of stories that might one day resonate across light years. This emotional thread ties us to broader implications. How do we preserve our world while reaching for others? Let's carry this thought forward as we explore the technological marvels driving our cosmic curiosity, blending human ingenuity with the dream of discovery. Let's now turn our gaze to the incredible tools and technologies that fuel our quest for other worlds, a testament to human ingenuity on this journey with Earth with nature. Picture the Hubble Space Telescope, a silent sentinel orbiting Earth, capturing images of distant galaxies with clarity that reveals planets as tiny specks against their host stars. Launched in 1990, Hubble has given us glimpses of cosmic wonder, like the iconic image of the Pillars of Creation, a stellar nursery where new worlds are born from gas and dust. But it's the newer James Webb Space Telescope, launched in 2021, that's revolutionizing exoplanet studies with its infrared vision, peering through cosmic fog to analyze the chemical makeup of alien atmospheres. Imagine this. Webb can detect traces of water vapor or carbon dioxide on a planet light-years away, offering clues to habitability. These planetary science facts aren't just dry data. They're windows into possibility, each spectrum a brushstroke on the canvas of an unseen world. Ground-based observatories like the European Southern Observatory's Very Large Telescope in Chile complement these efforts, using adaptive optics to correct for Earth's atmospheric distortion, achieving precision that rivals space-based instruments. Let's dive into a specific marvel. The transit photometry method, used by missions like Kepler, measures the minute dimming of a star's light as a planet crosses its face. A dip as small as 0.01% can signal an Earth-sized world. This isn't just numbers. It's a heartbeat of discovery, a rhythm of hidden planets calling to us. Now, consider the emotional weight of projects like the upcoming Extremely Large Telescope, set to be the world's largest by the late 2020s, with a mirror spanning 39 meters. It promises to image exoplanets directly, turning abstract data into tangible vistas. Imagine seeing the silhouette of a distant Earth for the first time. How would that change your perspective on our own planet's fragility? These technologies bridge the gap between us and the cosmos, but they also highlight Earth's uniqueness. No machine, no matter how advanced, can replicate the feeling of wind on your skin or the sound of rain. As we marvel at these tools, let's think about the challenges of reaching these worlds. Interstellar travel remains a dream, with even the nearest star, Proxima Centauri, requiring thousands of years with current propulsion. Concepts like Breakthrough Starshot, aiming to send tiny light-propelled probes at 20% the speed of light, offer hope, but they're decades away. This limitation reminds us to cherish our home while we dream of others, a theme we'll weave into the next layer of our exploration: the fragility of life in a universe of extremes. As we continue this contemplative odyssey with Earth with nature, let's reflect on the fragility of life amidst the harsh expanse of the cosmos, a theme that ties our search for other worlds to the urgent need to protect our own. Picture Earth as a delicate glass sphere, cradled in the void, its thin atmosphere a mere whisper against the vacuum of space. Planetary science facts reveal how rare this balance is. Mars, once flowing with rivers, now lies barren, its atmosphere stripped by solar winds over billions of years, a cautionary tale etched in its rusted plains. Data from NASA's MAVEN mission shows Mars lost its protective magnetic field, leaving it vulnerable, a fate Earth avoids thanks to its molten core generating a shielding dynamo. Now, imagine exoplanets facing similar perils. Many orbit red dwarfs, stars prone to violent flares that could sterilize a planet's surface. TRAPPIST-1, a system with 7 Earth-sized planets, fascinates scientists, but its star's temperamental nature might doom any budding life. This fragility isn't just physical, it's emotional, a reminder of how easily a world can slip from Eden to wasteland. Consider Venus again, with surface temperatures hot enough to melt lead, a stark contrast to Earth's temperate embrace. What if one wrong step, be it greenhouse gas overload or nuclear folly, tips us toward such a fate? The search for exoplanet mysteries often doubles as a mirror, reflecting our own vulnerabilities. Scientists model habitability indexes, quantifying a planet's life-supporting potential based on orbit, size, and star type, but Earth remains the gold standard, the only confirmed oasis. This uniqueness fuels projects like the Planetary Habitability Laboratory, which catalogs potential refuges, yet also underscores a sobering truth. We have nowhere else to go, not yet. Ponder this. How does knowing Earth's rarity shape your view of environmental stewardship? Every forest felled, every ocean polluted, risks unraveling the only sanctuary we know. As we gaze outward, missions like Europa Clipper, set to launch in 2024, seek signs of life under Jupiter's icy moon, reminding us that habitability might hide in unexpected forms. Subsurface oceans, perhaps, teeming with unseen microbes. This broadens our cosmic wonder, suggesting life could thrive beyond Earth-like molds, but it also deepens our duty to preserve what we have. Let's carry this emotional resonance forward, exploring how the search for other worlds reshapes our identity as a species, a topic that bridges science with the human heart. Let's now weave together the threads of identity and purpose as we near the end of our journey with Earth with nature, contemplating how the search for other worlds reshapes who we are. Imagine humanity as a lone storyteller, whispering tales into the cosmic night, unsure if anyone listens. The discovery of exoplanets, even barren ones, shifts this narrative. Suddenly, we're not just inhabitants of Earth, but potential citizens of a broader universe. This isn't mere fantasy. It's grounded in planetary science facts, like the Kepler mission's revelation that there could be more planets than stars in our galaxy, a staggering 100 to 400 billion worlds awaiting exploration. Each one, from gas giants to rocky orbs, challenges our self-perception. Are we pioneers, stewards, or simply fleeting sparks in an eternal dark? Emotionally, this search stirs a dual longing, for connection and for meaning. Think of the pale blue dot image, captured by Voyager 1 in 1990 from 6 billion kilometers away, showing Earth as a tiny speck in a sunbeam. Carl Sagan's words echo here. That's home. That's us. Every human being who ever was, lived out their lives on a mote of dust. This perspective, born of technology, humbles us, yet fuels our drive to reach beyond. Consider initiatives like the Artemis program, aiming to return humans to the moon by 2025 as a stepping stone to Mars. Each step outward is a test of our resilience, but also a mirror to our unity. What would finding life, even microbial, on an exoplanet mean for our sense of self? Would it unite us as a species, or fracture us with new questions of ethics and contact? The search for cosmic wonder through tools like the Square Kilometre Array, a future radio telescope spanning continents, promises to deepen this quest by mapping the universe with unprecedented detail, potentially catching signals of distant civilizations. Yet, it also reminds us of Earth's fragility. Our technology, no matter how advanced, is tethered to this single, irreplaceable world. As we ponder exoplanet mysteries, we're forced to ask, how do we balance exploration with preservation? This duality shapes our identity, urging us to dream big while grounding us in responsibility. Let's now venture deeper into the cosmic narrative with Earth with nature, exploring the unseen forces that shape worlds beyond our own and how they mirror the delicate dance of life on Earth. Consider the role of stellar evolution in crafting habitable zones, a process as ancient as the universe itself. Stars, like our Sun, are born from collapsing clouds of gas and dust, their nuclear furnaces igniting to forge elements, carbon, oxygen, iron, that later form planets. But not all stars are equal in nurturing life. Massive ones burn hot and die young in spectacular supernovae, often before planets can stabilize into cradles for biology. Red dwarfs, on the other hand, smolder for trillions of years, offering longevity but with a catch. Their habitable zones are so close that planets risk tidal locking, one face scorched and the other frozen. Planetary science facts reveal systems like Gliese 581, where Gliese 581g, if it exists, might sit in this precarious balance, a world of eternal twilight at the boundary of day and night. Imagine standing there, the sky a gradient of fire and ice. Could life adapt to such a stark divide? Scientists use models to simulate atmospheric circulation on such worlds, suggesting winds might redistribute heat, offering slivers of habitability. This isn't just theoretical. It's a glimpse into resilience, much like Earth's extremophiles thriving in volcanic vents or Antarctic ice. Reflect for a moment. How does the thought of life clinging to such edges stir your sense of wonder? It echoes Earth's own story, where life emerged against odds, perhaps in primordial oceans 3.5 billion years ago, as fossils like stromatolites suggest. Missions like the upcoming Dragonfly, set to explore Titan's methane lakes by 2034, push this curiosity further, seeking organic chemistry in alien landscapes. Titan, Saturn's moon, isn't Earth-like, yet its thick atmosphere and liquid cycles hint at possibilities beyond our norms. This search for cosmic wonder ties us to broader questions. If life can bloom in extremes, how many forms might it take across the galaxy? What lessons of adaptation can we draw for our own fragile ecosystems? As we ponder these exoplanet mysteries, we see Earth not just as a home, but as a laboratory of possibility, urging us to protect its diversity while imagining the myriad shapes of alien life. Let's carry this thread of resilience and adaptation into our next reflection, where we explore the chemistry of creation itself. Diving further into our journey with Earth with nature, let's unravel the chemistry of creation, the building blocks that stitch together worlds and perhaps life itself across the cosmos. Picture the early universe, a cauldron of plasma just after the Big Bang, cooling over eons to form hydrogen and helium, the raw materials of stars. Within these fiery crucibles, heavier elements are forged through fusion, scattered into space by stellar explosions to seed planetary disks. Planetary science facts tell us that Earth's carbon, the backbone of life, was likely born in such a dying star, delivered via comets or asteroids during our planet's violent youth. This cosmic recycling fascinates scientists studying exoplanets. Spectroscopy from the James Webb Space Telescope reveals water, silicates, and even organic molecules in distant worlds' atmospheres, hinting at shared origins. Imagine a planet like HD 189733b, a hot Jupiter, with glass rain driven by silicate clouds and 7,000-degree winds. Alien, yes, but composed of the same elemental palette as Earth. Could such chemistry, under different pressures, spark life unlike ours? Astrobiologists ponder this through experiments like the Miller-Urey test of 1952, which mimicked Earth's primordial soup, zapping gases to form amino acids, life's precursors. Now, consider the emotional weight of this shared chemistry. Every atom in your body, every breath, connects you to the stars. How does that reshape your sense of belonging in the universe? Projects like the Atacama Large Millimeter Array, ALMA, in Chile probe star-forming regions for complex molecules, finding sugars and alcohols in comet dust, suggesting life's ingredients are universal. Yet, Earth's recipe, liquid water, stable climate, protective magnetosphere, remains unique, a fragile alchemy. This contrast fuels exoplanet mysteries. Why did our world win the cosmic lottery while others, like Mars with its ancient water-carved valleys, faltered? As we explore, missions like Perseverance rover drill into Martian soil for signs of past microbes, reminding us life's spark is both tenacious and rare. This chemical kinship across worlds bridges to broader implications. How do we value Earth's unique brew while seeking its echoes elsewhere? Let's transition to the temporal vastness of this search, where time itself becomes a lens on habitability and loss. Let's now stretch our minds across the immense timescales that govern cosmic evolution, a perspective with Earth with nature that humbles and inspires in equal measure. The universe, born 13.8 billion years ago, unfolds at a pace beyond human grasp. Stars live for billions of years, while planets take hundreds of millions to cool and form crusts capable of hosting life. Earth's own story, spanning 4.5 billion years, is a mere chapter. Life took nearly a billion years to emerge, and complex organisms another 2. Planetary science facts highlight this patience. Fossilized cyanobacteria, dating back 3.5 billion years, mark life's slow crawl, shaped by eons of trial and error. Now, apply this to exoplanets. A world like Kepler 186f, an Earth-sized planet in a habitable zone 500 light-years away, might be younger or older than us. Is it a barren infant, or has it already passed through a biological golden age, now silent? Time is a silent sculptor, eroding atmospheres or fostering evolution. Imagine a civilization on such a world, rising and falling over millions of years. Would their ruins still whisper to us through radio echoes, or are we too late? The emotional pull of this temporal disconnect is profound. The search for extraterrestrial intelligence, SETI, scans for signals, but a message sent a million years ago might reach us as a ghostly relic of a dead world. How does this vastness of time make you feel about our own fleeting existence? Technology like the Gaia mission, mapping a billion stars with precision, helps us chart stellar ages, inferring planetary histories, yet it underscores Earth's fragility. Our window for intelligent life might be brief on cosmic scales. Consider the Great Filter hypothesis, suggesting advanced life hits a barrier, be it self-destruction or natural calamity, before spreading. Are we past it, or approaching it with climate crises and nuclear risks? This exoplanet mystery ties us to broader stakes. Preserving Earth might be our only shot at enduring through deep time. As we reflect on cosmic wonder, let's shift to the cultural narratives we project onto these distant worlds, exploring how they shape our dreams and fears. Continuing our exploration with Earth with nature, let's delve into the cultural lens through which we view distant worlds, a tapestry of human imagination woven into the fabric of science. Since ancient times, we've gazed at the stars, crafting myths. Greeks saw gods in constellations, while Polynesians navigated by celestial maps, tying their identity to the heavens. Today, exoplanets fuel similar storytelling, blending cosmic wonder with hope and dread. Science fiction, from H.G. Wells' War of the Worlds to modern films like Interstellar, paints alien planets as utopias, battlegrounds, or mirrors of our flaws. Consider how the discovery of TRAPPIST-1's 7 rocky planets in 2017 sparked art and speculation. Could they host peaceful societies or warn of overpopulation's perils? Planetary science facts ground these dreams. Each world's orbit and mass, measured by radial velocity techniques, offers a canvas for possibility, yet reminds us of reality's constraints. Emotionally, this duality grips us. Hope for a second Earth clashes with fear of finding desolation or hostility. Reflect on this. How do your own stories of alien worlds shape your view of humanity's future? Projects like naming exoplanets, where public campaigns christen distant orbs, show our need to humanize the unknown. Kepler 452b became a symbol of hope, dubbed Earth 2.0, despite unknowns about its surface. Technology amplifies this, with virtual reality simulations letting us walk on exoplanet landscapes based on data, fostering connection. Yet, Earth remains our only true story, its cultures and histories irreplaceable. Exoplanet mysteries push us to ask, do we seek other worlds to escape, or to better understand home? This cultural interplay reveals broader truths. Our search is as much about self-discovery as exploration. Let's pivot to the ethical dilemmas of this quest, where science meets moral responsibility in the cosmic expanse. Let's now navigate the ethical currents of our search for other worlds, a profound layer of reflection with Earth with nature that ties discovery to duty. As we probe exoplanets with telescopes and dream of interstellar probes, we face questions of intent and impact. Should we broadcast our presence, as with the Arecibo message of 1974, a radio signal sent to the Hercules cluster, risking attention from unknown entities? Planetary science facts under the stakes. While Proxima Centauri b is near, a mere 4.2 light-years, any response to our signals would take decades, if not centuries, assuming benign intent. Imagine a scenario where contact brings not alliance, but conflict. Science fiction often warns of this, yet real policy, like the UN's Outer Space Treaty of 1967, lacks specifics on alien interaction. Emotionally, this stirs unease. Are we ready for the consequences of being heard? Ponder this. Would you advocate silence or outreach, knowing Earth's fragility? Technology like Breakthrough Listen scans for alien signals with AI, analyzing billions of frequencies, but finding life, even microbial, raises issues of contamination. NASA's planetary protection protocols, enforced during Mars missions, aim to avoid cross-contaminating worlds, preserving their natural state. What if we terraform a barren exoplanet like Mars for human survival? Do we have the right to alter another world's destiny? These exoplanet mysteries resonate with broader ethical dilemmas. Exploration versus preservation, curiosity versus caution. Earth's history, colonial exploitation, environmental harm, warns against repeating mistakes on a cosmic scale. As we seek cosmic wonder, initiatives like the METI, messaging extraterrestrial intelligence, debate whether active signaling is reckless or essential. This moral crossroads mirrors our stewardship of Earth. Protecting rainforests or oceans parallels safeguarding alien ecosystems we've yet to see. Let's carry this ethical weight into our final extension, examining how the search for other worlds might redefine our future as a species. As we reach the final stretch of this extended journey with Earth with nature, let's contemplate how the search for other worlds might redefine humanity's future, a vision blending science with aspiration. Imagine a day when we confirm life on an exoplanet, perhaps through biosignatures detected by the European Space Agency's Ariel mission, set for 2029, which will study 1,000 alien atmospheres. Such a discovery could galvanize us, uniting nations in a shared quest, much like the Apollo program did in the 1960s with 400,000 people collaborating for a lunar dream. Planetary science facts suggest this isn't far-fetched. Statistical models estimate 10 to 20% of Sun-like stars host Earth-like planets, implying billions of candidates in our galaxy. Yet, this future holds challenges. Interstellar travel, even to Proxima Centauri, demands breakthroughs in propulsion, perhaps nuclear fusion or wormhole theory, still decades or centuries away. Emotionally, this horizon inspires both awe and impatience. Could your descendants walk alien soil, or will Earth remain our only stage? Reflect on this. How would confirmed alien life alter your worldview or humanity's priorities? Technology races forward. Concepts like the starshade, a massive screen flown with telescopes to block starlight, could image exoplanets directly by the 2030s, offering visual proof of distant worlds. But this future isn't just about reaching out. It's about looking inward. Finding life might redefine Earth as a sanctuary to preserve, not abandon, echoing lessons from climate science where models predict tipping points if warming exceeds 2 degrees Celsius. Exoplanet mysteries thus frame a dual path: explore with humility, protect with urgency. As we chase cosmic wonder, we must ask, are we building a legacy of curiosity or recklessness? This extended reflection ties the vastness of space to our intimate choices. We urge you to continue this exploration. Research the latest in exoplanet science. Share your visions of humanity's cosmic future in the comments, and like this video to support Earth with nature. Subscribe for more immersive journeys, and let's keep pondering together. How will the search for other worlds shape the story of our own? Until next time, gaze at the stars, cherish our fragile home, and dream of what lies beyond.